so section 2 is a review of important pre-calc concepts. So this section is very, very long, so we're going to break it up into 2 parts. All right, so the first part, we're going to talk about horizontal and vertical asymptotes. All right, if you remember from Algebra 2, there are some tricks to finding horizontal and vertical asymptotes. So the first one's pretty easy. A vertical asymptote is going to be the denominator is equal to 0. Okay, so you're going to set your denominator equal to 0. All right, so I'm going to do 4x squared minus 2x plus 1 equals 0. And unfortunately, I think this was a typo on my part. It does not factor, does it? So we do quadratic formulas. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get 2 plus or minus, and then we have 4 minus 16. So we have negative 12 under there. So what does this mean about vertical asymptotes? It doesn't exist. There are no vertical asymptotes. Remember, we do not have square roots of negatives in calculus. In Calc 1, we do not do that. We will not deal with any imaginary numbers, complex numbers, right? Okay, so the horizontal asymptote. The horizontal asymptote, it was cheesy in Algebra 2, but maybe you remember, I always said, there's a shortcut. So you don't have to do the big old long thing, you can always just do a shortcut. And what that shortcut is look for your largest degree. So we're going to look for the largest degree in any location. So in this case, our largest degree is x squared, and we have it both on the numerator and the denominator. And we ignore everything else. Okay, so we're going to ignore the 3, the 2x, and the 1. So we get y equals 2x squared over 4x squared, which reduces to just plain 1/2. So y equals 1/2 is our horizontal axis. Very easy shortcut. We will talk about the longer method later in the year. All right, so if I have f of x equals 5 minus x over x squared minus 3x plus 2, my vertical asymptote is going to come from setting my denominator equal to 0. And I factor, this one does factor, into x minus 2 and x minus 1. So our 2 vertical asymptotes are 2 and 1. When we do the shortcut for the horizontal asymptote, we look for our largest degree. Our largest degree is x squared. But now we don't have any x squared on the top. So what we do is when we are missing the largest degree, we put it in. So we do 0x squared all over 1x squared. So when we do that, we get 0 over 1, which is 0. So that means we have a horizontal asymptote of y equals 0. Okay, part C is a little bit tricky. So in order to do this one, I want you guys to get your calculators out and go ahead and graph it. So when you put this in for y1, I want you to do parentheses 1 minus x divided by square root parentheses x to the 2 minus 4, like that. And I have this fancy program that will let me do it up here as well. I know, fancy, right? All right, so that's an old one. Hang on. So I'm going to go to y equals It takes me forever to do this because I have to click every single thing, so bear with me. So if you're ever watching the video, you can always fast forward, right? All right, so I have x squared minus 4. Okay, so we're going to hit graph. And make sure that you have it in the standard 10 by 10 window, and you can do that if you can't see exactly what my graph looks like on your screen. Hit zoom, and then you can see it has all these different zoom options. I want you to go to Z standard, zoom 6, and that puts the standard -10 to 10 for x and -10 to 10 for y. Okay, so do you guys see that? Where does it look like the horizontal asymptote is? It looks kind of like 0. But if you zoom in, and maybe I change the window, So let me say I change the window and I go way out on the right side. Like I go from 500 to 1,000. And then I zoom in for my y's, and I say, oh, let's just make our y's from -2 to 2. I did. I don't think you get a bonus point for that. That's just clicking stuff. It's just my fingers tired. All right, and then, all right, so I hit graph. So we're way off on the right side of the graph. Does it look like it's getting closer to 0? No, it actually looks like it's getting closer to negative. You guys see that? So the horizontal asymptote for this one, there's actually 2 of them. So one of them is getting closer to 1, and one is getting closer to -1. All right, so we're going to talk about why that is. So our horizontal asymptotes are y equals 1 and y equals -1. All right, so I told you that the shortcut for finding a horizontal asymptote is to find the largest degree. But when you look at this one, it looks like your largest degree is x squared, but it's not really, because that x squared is under square root. Okay, so your largest degree is actually going to be something in the form of x to the first. You understand that? So it's going to be x to the first, and we do have an x to the first on the top. So when you look at it, you're like, okay, well, I have -x over the square root of x squared, and I know that the square root of x squared is x. That's what we all think it is. And it's not. Nick, you're shaking your head. What is it actually? It is the absolute value of x. You are correct. Oh, such a good algebra 2 student. You remember that from algebra 2. Do you guys remember that? So back in algebra 2, I told you guys that if you had -5 and you squared it, you didn't actually get -5 when you took the square root. You got the square root of 25, which was 5. But if we took 7 squared under a square root, we didn't get -7, right? We got square root of 49, which is indeed 7. So it's tricky. So I told you in algebra 2 that whenever you have an even root and you ended up with something raised to an odd power, which you do, x to the first, you had to put absolute value around it. And you thought that we were just doing that for one section and we were going to be done with that for the rest of your math career, and we're not. It's sad. So we do have to consider that. All right, so basically, if you want to remove an absolute value, what we do is we put a plus or minus. You remember when we had absolute value equations, and I told you that you could remove the absolute value by doing plus or minus 5. It's the same idea. It's just what we're saying is that the plus or minus really was over here. Removing an absolute value means we have plus or minus. So we have the plus or minus. So we have -x divided by positive x, which would be -1, and we have -x divided by -x, which would be 1. So we get both answers. We get the relative. So we'll revisit that when we talk about limits, but I wanted to mention that here. All right, the vertical asymptote, that's much easier. We have the square root of x squared minus 4 equals 0. So in other words, x squared minus 4 is equal to 0, so we can see that that would definitely be plus or minus 2. What if it had been x squared plus 4? Would there be any? No, there wouldn't be any vertical asymptotes, right? All right, so the next one, f of x equals x to the 4th plus 5 all over x cubed minus 1. So our vertical asymptote, we set our denominator equal to 0. Technically, we should factor, right? It's not just 1. There's actually 3 solutions because it's an x cubed equation. Any degree that you have tells you the number of solutions that you have. There's actually 3. You would factor. This is the thing that I taught you, which was so same, opposite, always positive. You guys are all like panicking. I can see the looks on your face. You're like, oh my gosh, I forgot all this stuff. So you're going to do the first thing squared, the last thing squared, multiply the 2 together, 1x. So the lucky thing is that this one here has complex solutions, or imaginary numbers. Okay, so we actually don't have to really do that anymore. So if you took summer pre-calc, I talked about something called roots of unity. Those 2 solutions are imaginary solutions. If you had a Mr. Morrison last year, he just skipped that section. He doesn't like it, so he just skipped it. It's okay, it's not like a big deal. All right, so anyway, so we do get x equals 1 regardless. The other answers were complex. All right, horizontal asymptote. Look for your largest degree. So it's x to the 4th, so we have 1x to the 4th all over 0x to the 4th. So we get 1 over 0, so what do we write? It's undefined. What do you think that means? Yeah, there's none of them, right? So no horizontal asymptotes. Does that all make sense? So vertical denominator equals 0. Horizontal, do the shortcut method. All right, so the domain. It kind of has something to do with the vertical asymptotes type thing, but domain doesn't just have to be denominators. So for domain, I want you to look for even roots, denominators, and logs. So you can't take the even root of a negative number. You can't take a denominator and have it equal to 0, right? You can have a 0 in the denominator. And you can't take the log of a negative number or 0. So log of 0 doesn't exist, log of a negative number doesn't exist. Okay, so those are the three things that we're going to look for. So on this first one, we have a denominator. So we want to find out what makes our denominator equal to 0, the bad numbers. So we factor. This is one of my favorite ones to put on the test because I don't have to think about the signs, and if it actually factors, it will always factor, no matter the sign. So be very careful. So we have 2x and x. We need our signs to be the same, and they need to combine to be a -5 in the middle. So they need to both be negative. So you can't put the 3 on the outside and the 1 on the inside because that makes -7. Do you guys understand that? So you're going to need the 3 on the inside and the 1 on the outside. A lot of people mess up the signs on these. All right, so we get x equals, well, let me write it out. 2x minus 3 equals 0. And x minus 1 equals 0. So we get x equals 3 over 2 and x equals 1. Okay, so those are the bad ones. Those are the ones that cannot be in the domain. Everything else works. Anything that you plug in for x besides those two numbers will give you some kind of output, right? So the way we'd write the domain, don't write this, but if I was asking you to write it in an interval notation, it would be -infinity to 1, union 1 to 3 over 2, union 3 over 2 to infinity. That's a lot. So the easiest way to write the domain is just to say that x can't be 3 over 2 and 1. Right? I could say all real numbers except for 3 over 2 and 1. All right, so part B has both a denominator and square root. All right, so we can't have our denominator equal to 0. So what can we automatically not have? What makes the denominator 0? What's one number? I'm going to call you this. 5 and -5, right? Those are both bad. We can't have those. Okay, so what I want you guys to do is when you have a square root, you always say 25 minus x squared has to be greater than or equal to 0. But in this case, I'm just going to say greater than 0. Because it can't be equal to 0 because it's on the denominator too. And this is why in section 1 we learned about critical values. So really this is a critical value type problem. So you would factor, you'd say 5 minus x and 5 plus x. So you'd have two critical values, 5 and -5, and you would put them on a number line. And you would test in the left, in the middle, and the right. But I think you're smart enough to not have to plug in these different things and see if it's true or false. Just think about it. When you have that square root of 25 minus x squared, can you plug in 6 for x? No, 33, right, you get 25 minus 36, it doesn't work, right? So anything over here doesn't work. Can you plug in -6? Nope, same reason. Can you plug in anything between -5 and 5, like 4? Yep, you can. So it's in the middle that you want. It's going to be open circles on there. So it's going to be -5 to 5 for our domain. All right, so I said you can't take the log of a negative number. You also can't take the log of 0. So whenever you see a logarithm, I want you to take this part and it needs to be greater than 0. So you're going to say 2 minus x has to be bigger than 0. So we have 2 is greater than x, which I will typically write as x is less than 2. I don't like the x on the right. I like the x on the left. All right, so you can leave it like that, or you could write it as -infinity to 2, for instance. Either way. So I'm not really particular about how you're writing it. All right, and then part D has both a square root and a logarithm. So we know from the logarithm part that x has to be greater than 0, and we know from the square root part that 2x minus 1 has to be greater than or equal to 0. So we get 2x is greater than or equal to 1, so x is greater than or equal to 1/2. So what we're saying is when we have domain and we have multiple things for the domain, we have to say that every single one of them has to be true. So x has to both be greater than 0, and x has to be greater than or equal to 1/2. So here's what it looks like on a number line if you're a visual person, you want to see it. We're saying that x is bigger than 0, but x is also greater than or equal to 1/2. So we're finding the overlap. So what do we write? X is bigger than, yeah. So it's negative 1/2. Yeah, it's all good. Good try though. What's that? I like the people that go for this one. All right. So what do you write for your final domain? Okay, 1/2 included. To infinity, right? Good. All right, does that make sense? You need both things to be true. And if you think about it, like let's say you try 1/4 there. If you try 1/4, but you plug it into the numerator, you get the square root of 2 times 1/4, which is 1/2 minus 1, the square root of negative 1/2. It doesn't work, right? So that's why it can't be part of the domain. All right, so this is probably the most important part of this section. This is the part, man, everybody always thinks like, oh, we don't need sine and cosine. We took pre-calc, we're good now. No, like we do it every day. So if you have trouble with sine and cosine, you need to see me as soon as possible. Some people last year I kept saying, see me as soon as possible, see me as soon as possible. If you don't understand, come find me. And then in May, they're like, oh yeah, I still don't know sine and cosine. I'm like, are you kidding me? The whole time you don't know them. All right, it's important. All right, so the first thing, so I have sine of x equals negative square root of 2 all over 2. So you can have your unit circle out if you feel like you need it. The sign is the y value in your unit circle, so let's write that. So y value. So I don't ever draw the entire unit circle on an assignment or a test or anything like that. I just draw a little tiny one. So I draw a little tiny unit circle, and I say that the y value, right, sine, has to be negative root 2 over 2. So if the y is negative, I'm in the third quadrant and the fourth quadrant, and I'm right in the center of those quadrants. So I think about what those values are. Now notice I said give all answers on the domain 0 to 2 pi. We are in radians. We will always be in radians in calculus. We will never be degrees. So I know you guys really like degrees, but we won't do it. All right, so anybody know what those are? 5 pi over 4 and 7 pi over 4. Okay. You know? Yeah. All right, so that's our angles. All right, so the next one, I have cosine squared x equals cosine of x. Okay, this is just like one that I gave you guys the other day where I said x squared equals 5x. A lot of people try to divide out by x, but you actually can't do that because you use the solution x equals 0. So what you would do to solve this problem is you would subtract over, you would pull out the common factor, and that would give you the two solutions, x equals 0 and x equals 5. So same idea here. Even if it's trig stuff, sine, cosine, tangent, right, you still can't divide out by that cosine of x. So you want to subtract it to the other side, and then pull out the GCF. So the GCF is cosine of x. So you get cosine of x minus 1. You all know that this cosine squared x is the same as cosine of x times itself, right? It's where I don't know that notation. We get lazy, we don't like to do lots of parentheses and trigs. All right, so we set each thing equal to 0. So I have cosine of x equals 0. And then we have cosine of x minus 1 equals 0, which means cosine of x equals 1. So I draw my little bitty unit circle. Draw another one for this one too. So the cosine is the x value on your unit circle. So we're saying when you have an x value of 0, so up at the top and at the bottom, right? You have 0, 1 and 0, negative 1. So that is going to be pi over 2 and 3 pi over 2. All right, and then the other one, cosine of x equals 1. So we only have one point that has a 1 for the x. It's over here on the right. So we write x equals 0, and you might even be tempted to write 2 pi, but you don't need to. Why do I not need 2 pi? Because it said what? It is the same location, but look at your domain originally. I said give all answers on the domain, 0 to 2 pi. Right, it doesn't have like the bracket on the 2 pi. So since it doesn't have a bracket, you don't need to include it. And it might be different on the homework. Like maybe I have 0 to 2 pi, open bracket, then include it. Okay. So it kind of depends. So we have x equals 0 as well. All right, so this next one, I didn't realize I did this. Sine of 2x, you probably don't remember this from pre-calc, but it's 2 sine of x cosine of x. Those of you that took summer pre-calc might remember that, but those of you that haven't been in pre-calc since June probably forgot. So I really should have written this problem instead. You don't actually need to know all of the identities that you had from pre-calc. Is that like a, yay, they're hard. All right, so we get everything on one side. And we pull off a GCF of sine of x. And we're left with 2 cosine of x minus 1 equals 0. So we set each piece equal to 0. So we get cosine of x equals 1/2 and sine of x equals 0. So I added the 1 divided by 2. So I think about my little miniature unit circles. So sine of x is equal to 0 when the y value is 0, so it'd be here and here, left and right side. Cosine is equal to 1/2. That means I go over just a little tiny bit, and then I go up √3/2 and down √3/2. So I'm definitely in the first quadrant and fourth quadrant. My x value is positive, and I'm here and here. You see it? So over a little, up a lot, over a little, down a lot. So my values are 0 and pi, and the other ones for the 1/2, cosine of x equals 1/2, are pi over 3 and 5 pi over 3. So I know you're probably not like super speedy on those now. That's okay. You can have your unit circle in front of you for now, but you will get better at them throughout the year. All right, so next one is cosine squared x equals sine squared x. So you could do lots of different things. You could use your Pythagorean Identity. Some people suggested that in the last class. So you can use the fact that cosine squared x is really the same as 1 minus sine squared x. You can do that. I just did the square root of both sides. Is that what you were thinking? But remember, when you take the square root of both sides, you have to write plus or minus. The square root, but you have plus or minus on both sides. All right, so it's a little weird. Like, imagine I have plus or minus x equals plus or minus 3. Okay. Putting a plus or minus on both sides is kind of redundant. You don't need to do that. Right? The reason is because both of them positive would be x equals 3. Both of them negative would end up being the same thing. If negative x equals negative 3, it's still x equals 3. One of them negative or the other one negative, that gets the same result as well. You can divide out by the negative. So really you just need it on one side, so we can cross one of them out. So we get cosine of x equals plus or minus sine of x. So let's start with the plus. When is cosine of x equal to sine of x? How many locations on the unit circle does that happen? 2, right? What quadrants? Right, the first and the third. It happens right there in the center. Because we have √2/2, comma √2/2. Cosine and sine are the same. In the third quadrant, we have negative √2/2, comma negative √2. Okay? Where are cosine and sine opposite each other? Right, the second and fourth, right? The other two. So that means our values for x are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so is this all kind of coming back to you? Are any of you like super nervous? You're nervous for getting some of this? Okay. All right, so go ahead and try E. I was trying to sneakily do it along with you. But... All right, so did you at least get cosine of x equals √3/2? You have that in there somewhere? All right, so you're saying the x value on the unit circle is positive, and it's √3/2, right? So you're going to be in the first quadrant and fourth quadrant, and you're going to go over further than you go up. Okay, so those locations are going to be like the 30-degree ones. So it's going to be pi over 6, and the other one's 11 pi over 6. So it's pi over 6 away from being at 2 pi. Remember, 2 pi is 12 pi over 6, so it's back out at pi over 6. Does anybody get all of that? Get all of it? Good. All right, so this next one you can do a couple different ways. You could subtract the 1 over, you could factor, or you can divide by 4 and have 1/4, and then take the square root. Just remember, whenever you take a square root, write your plus or minus. So you have sine of x equals, the square root of 1 is 1, the square root of 4 is 2, so plus or minus 1/2. So we're saying when is sine equal to positive 1/2, and when is it equal to negative 1/2? Yeah, if you did like, as long as you did the 2, right? So she asked, could you take the square root first and have 2 sine of x equals plus or minus 1? That's fine. Just don't forget to take the square root of the number as well. So we get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, on G, we don't have a set equal to 0, so we can't pull out that GCF. This is a factoring problem, though. It doesn't look like a factoring problem at first. It looks a little bit hard, right? But you're going to get everything set equal to 0. So you're going to subtract the 1 over. And basically, you're thinking of it like a W substitution. So we mentioned that the other day. So it's just like if you had 2W squared plus W minus 1, you would know how that factors. Right? You'd say, oh, I just have a 2W and a W, and I have a 1 and a 1, but they need to be opposite signs. And those outer and inner sweeps need to combine to be a positive 1. So you need a positive on the outside and a negative on the inside. All right, does that make sense? So it's the same idea even though you have signs in this problem, right? So what you're going to do is you're going to factor, and you're going to have 2 times sine of x, and then in the other parenthesis you're going to have just plain sine of x, because those first spots multiply to be 2 sine of x squared. All right, and then you have a 1 and a 1, and the outer and inner need to combine to be a positive 1 sine of x. Yep, so it's like that. So now you set each thing equal to 0. So 2 sine of x minus 1 equals 0 means sine of x equals 1/2. And the other one is sine of x equals negative 1. So we think about where sine of x is equal to 1/2. We just did that. That was the pi over 6 and the 11 pi over 6. Oh, no, not 11 pi over 6. Ooh, almost got me. So it'd be pi over 6 and 5 pi over 6. Right, positive 1/2. And then where it's equal to negative 1 would be 3 pi over 2. So your answers are pi over 6, 5 pi over 6, 3 pi over 2. All right, I made a bit of a typo on H, so make the 3 a 5. So edit H and make the 3 a 5. All right, so we're going to factor again. So we're thinking of it like a W substitution. Hopefully you don't need to write the W's down. So you're going to have a 2 cosine of x and a cosine of x. And you're going to have a negative 1. Oh, it is cosine and sine. I forgot. Okay, so I covered up my sign. I need to use the Pythagorean identity. So I told you don't need to know very many identities. The ones you need to know are the quotient identities, like 1 over sine is cosecant, 1 over sine is, or 1 over cosine is secant. You guys know all those. The other one you need to know is this one. Sine squared x plus cosine squared x equals 1. So what we're going to do is we're going to replace this cosine squared with 1 minus sine squared. So that way we get them to be the same thing. So we're going to have 2 times 1 minus sine squared minus 5 times sine of x plus 1 equals 0. And we're going to continue to simplify. So we're going to have 2 minus 2 sine squared x minus 5 sine of x plus 1 equals 0. So negative 2 sine squared x minus 5 sine of x plus 3 equals 0. So if you're really OCD like me, you don't like having negatives up front when you're factoring. You guys like that? I need it. So we're going to make this plus, plus, and minus. We're just dividing by negative 1. And then we factor. Sorry, I'll let you on just a second. I'm a little bit long. All right, so when we factor, the signs need to be opposite, and they need to combine to be a positive 5. So we're going to do a plus 3 on the right side and a minus 1 on the inside. See how it makes 6 sine of x on the outside, and the inner terms are minus 1 sine of x. So what we're finding is when sine of x equals 1/2, and where sine of x equals negative 3. So how about the sine of x equals negative 3? That can't happen, right? I see some head shaking. No. The smallest that sine of x can be is negative 1, right? So this part gives me a no solution. Oh, can sine of x equal 1/2? Yeah, we've done that one a couple times today. So it's here and here. So you get 5 pi over 6. Oops, messy. 5 pi over 6 and pi over 6. So those are your two solutions.